Evolution, where construction meets innovation.
Evolution. Let's build the future together.
So you sent over some really interesting sources about cyber-physical systems, especially in construction and real estate.
That's right.
And our job, like always, is to kind of pull out the main ideas, the important stuff, so you, the listener, can get informed quickly without wading through everything.
Exactly. Get right to the core of it.
Let's jump in.
Absolutely. The materials you shared, they really show a big shift happening. It's about how we think about buildings, really, from the very start, the design, all the way through to how they're managed day to day.
Okay, so let's start right at the beginning. Cyber-physical systems, CPS. What is that, basically?
Okay, think of it as a really tight link between, the physical stuff, buildings, equipment, even people, and the digital side, the software and the data.
Right.
But the really crucial part is the constant connection, the back and forth. You've got sensors picking up real-time info from the environment.
Mm-hmm.
That data gets processed, usually by software algorithms, and then the system can actually do something in the physical world, maybe through actuators.
Actuators, like things that move or control something.
Exactly. And humans are definitely part of this loop as well, interacting with it, getting feedback.
Okay, that kind of rings a bell. It sounds a bit like our discussion on smart cities, just maybe more focused.
Precisely. Yeah. Smart cities are like a massive example of this kind of connect thinking. Here, we're just narrowing it down, looking specifically at buildings in real estate.
So practically speaking then, how is the CPS stuff being used today in construction or property management? What can it actually do?
Well, the main goal is usually better control, better optimization of how buildings work.
Okay.
And that leads to some pretty big benefits like much better energy efficiency, improved safety because you're monitoring things all the time, and overall buildings that are more sustainable and, well, responsive.
Now, one source mentioned something slightly different, human-centered cyber-physical systems. HC-CPS, that sounds like it adds another layer.
It does, yeah. What's interesting there is the focus, the deliberate focus on the person using the system.
Right.
So while your standard CPS might be technically brilliant, HC-CPS really prioritizes the user experience. Is it easy to use? Is it intuitive? Does it actually help the person?
Oh.
And real-time feedback is a big part of that, too. The system can kind of learn and adapt to what you need or prefer.
So it's not just about the wires and code working in the background, it's making sure it works well for people.
Exactly. Making it seamless, positive.
The source laid out some key differences. Maybe we can quickly run through those.
Sure. So the main goal for standard CPS is that deep integration, physical and digital. But for HC-CPS, it's really user-friendliness, making it work smoothly for humans.
And the main focus then shifts from just technical function.
To the user experience, yeah.
Yeah.
How does it feel to interact with?
Got it. And user interaction, is that different?
Definitely.
Yeah.
A standard CPS might not involve much direct user fiddling. HC-CPS puts the user right in the middle. The system's designed to respond to them, adapt.
So the development approach changes too, from tech first to
user first, interaction design first, absolutely. Thinking about needs from the start.
And where would we typically see these different types? The application areas?
Well, traditional CPS, you often find it in like industrial automation, big factories. HC-CPS is maybe more aimed at making buildings, workplaces better for the people in them, enhancing comfort, productivity.
Right. And the source gave a simple example to contrast them.
Yeah, like an automated production line that's classic CPS versus, say, an intelligent building that learns you like it cooler and adjusts the AC for you that's more HC-CPS. It responds to preference.
That clarifies it, that human touch.
Exactly. Now, for today's chat, we'll probably just use CPS mostly as a general term.
Okay.
But it's really important to keep that user-centered idea in mind. It's becoming more and more critical.
Understood. Okay, so let's dig into those application areas now. Within construction, within real estate, where is CPS actually making a difference?
Well, one of the biggest areas is definitely intelligent building management. Imagine a building that's constantly aware of its own energy use, the lighting, the climate control, all in real time.
Right.
CPS makes it possible to adjust these things dynamically, optimize everything for peak efficiency. This can seriously cut down the building's environmental impact.
And presumably save money too.
Oh, absolutely. Significant cost savings, plus that real push towards, actual sustainability. It's a powerful mix.
That is compelling. What's another major area?
Security management is another big one.
How so?
Well, CPS can monitor building spaces continuously. It can spot potential risks, maybe unusual movement patterns, somebody trying to access somewhere they shouldn't.
Uh-huh.
And it can trigger responses proactively, often before something bad actually happens. So it's moving from just reacting to predicting and preventing.
That's a significant shift. So what's the tech making this all possible? What's under the hood of these CPS?
Foundational, really, is the Internet of Things, IoT.
Right, we hear that term a lot.
Basically the huge network that lets all these physical things, sensors, controllers, building systems, talk to each other seamlessly and generate that constant stream of data.
It's like the building's nervous system.
That's a great way to put it, yeah.
Yeah.
For the smart building or the construction site.
And all that data flowing in, what happens to it? It must be overwhelming.
That's where AI and machine learning step in.
Hmm.
Artificial intelligence, ML.
Okay.
These algorithms, they can sift through massive amounts of data, find patterns, spot anomalies maybe a human would miss,
Right.
and then automate the optimization. They can learn over time, adapt to changes. That's what makes the building genuinely smart, responsive.
The sources also touched on AR and VR,
Yeah.
augmented and virtual reality. Where do they fit in?
Yeah, AR and VR are mostly changing things in the planning and the execution stages of construction.
Right.
They offer these really immersive ways to like visualize a design before it's built, do virtual walkthroughs, or even give workers on-site real-time info overlaid on what they're actually seeing. Guidance, instructions, that sort of thing.
So maybe not part of the building's ongoing operation, but key in getting it built right.
Exactly. Powerful tools for creating and maintaining these smart environments, even if they're not always on in the same way as the energy systems.
So we've got this mix of connected devices, smart software, immersive tech. What are the big picture advantages of using CPS?
The upsides are pretty significant, and they cover a few areas. Big gains in efficiency, definitely. Because the system responds in real time, optimizes things dynamically.
Makes sense.
Safety gets a major boost, too, through spotting risks early, mitigating them.
Right, the proactive security.
And then there's sustainability, cutting energy use, reducing environmental impact. These aren't just small tweaks, it's a potential step change in performance.
Those are definitely strong selling points. But it can't all be straightforward. What are the hurdles, the main challenges in actually implementing CPS?
Well, data privacy and security are huge, absolutely critical.
Yeah, I can see that.
When you have all these connected things collecting data constantly, they become targets, right? Cyber attacks are a real concern.
Mm-hmm.
Then there's the challenge of integration. Trying to mesh these new CPS technologies with existing building systems or IT infrastructure, that can be really complex, especially if the existing stuff is older.
Yeah, legacy systems.
Exactly. And finally, you can't forget user acceptance. People actually have to trust these systems, be willing to use them, engage with them for the whole thing to work effectively.
So it's not just a tech problem, it's a people problem too.
Absolutely. Adoption is key.
Okay, those are important points. The sources then went into some specific pilot projects, which really helps make this concrete. Let's look at the first one, integrating CPS in building management.
Right. This was an early important study. The main idea was to make project management work better by creating a two-way street for information between BIM.
Building information models, the digital blueprints.
Exactly. Between BIM and the actual physical construction site. The real breakthrough was getting that real-time data flowing from the site back into the digital model.
So the model wasn't static anymore.
No, it was live, reflecting reality. They used sensors, other CPS bits, to feed data about progress, conditions on site, straight into BIM.
What did that achieve?
It gave project managers a much, much clearer, more up-to-date picture. They could spot problems faster, react quicker, make adjustments. It wasn't just monitoring. It allowed for proactive changes that cut down mistakes, rework, delays, all costly things.
And the results bore that out.
They did. They saw real improvements in efficiency, in the accuracy of the information. Communication, collaboration between teams got better.
Fewer errors?
Yeah, significantly fewer errors and less rework. It was the bottom line. Lower costs, shorter project times. A really strong case study.
Okay, the second project tackled something different but just as practical, making it easier to connect new CPS with old IT systems.
Yeah, this one addressed a real headache. Plugging shiny new tech into older, maybe clunky, existing IT infrastructure can be incredibly difficult and take a lot of time.
The integration effort.
Exactly.
Yeah.
So their goal was to find ways to automate that, make it less manual, less painful.
How do they try to do that?
It's quite technical, involving something called annotated application code and semantically enriched information models.
Okay. What does that mean in simpler terms?
Think of it like adding really detailed smart labels and instructions right into the software itself. These labels help different systems understand each other automatically without a human having to translate everything manually.
Ah, so it helps them talk the same language, basically.
Kind of, yeah.
Yeah.
Reduces the friction. And the result was, well, a big drop in the manual work needed for integration.
That sounds valuable.
It also made the combined systems more reliable, easier to maintain and update later, and more flexible, too, easier to add more new tech down the line.
Good stuff. Okay, Pilot 3 brought the focus back to the actual construction work itself. What was the goal there?
This project was about making sure the physical things being built, the columns, beams, whatever, perfectly matched their digital counterparts, their digital twins, throughout the whole process.
Maintaining consistency.
Yes, bidirectional consistency. They looked at things like tracking exactly where components were placed, monitoring temporary structures like scaffolding for safety,
Important for safety, yeah.
and even making mobile crane operations safer on busy sites. It's about having that real-time digital eye on critical physical tasks.
So better oversight.
Better oversight, better control. They tested prototypes on actual construction sites and showed it really could improve how things get built. Fewer mistakes, less need to fix things.
Which means?
Increased efficiency, cost savings, naturally. And because everyone had access to the same accurate, up-to-date data, collaboration got better too.
Makes sense. Okay, the last pilot project focused on quantity surveying and cost control. Always a critical area.
Oh, absolutely. Keeping track of costs is fundamental. This research looked at how CPS could make those quantity surveying workflows, more efficient, more accurate.
And how did they approach it?
They did a series of in-depth interviews with people working in the industry, quantity surveyors, cost managers.
To find out what they needed.
Exactly. To identify which specific CPS technologies could be most helpful and how they could be applied in that context.
And what was the main potential they identified?
The big takeaway was the possibility for much tighter, more precise cost control by directly linking what's actually happening physically on site.
Like how much concrete has been poured.
Yeah, exactly.
Yeah.
Linking that physical progress directly to the digital cost management systems.
Okay.
This gives you much better transparency, much better accuracy in tracking costs as they happen, not weeks later, which in turn means better project control overall, more informed decisions about spending. It's about real-time financial awareness.
So these 4 projects, they cover quite a range, don't they? From project management integration to easing IT headaches to on-site execution and finally cost control.
They really do. The sources had a nice summary table comparing them.
Let's quickly recap the highlights from that. Project 1, the BIM integration one.
Right. Objective was efficiency using sensors and CPS linked to BIM. Key result, better efficiency, fewer errors. A challenge was integrating with existing processes, application, real-time site adjustments.
Project 2, the integration effort one.
Goal, reduce integration effort, tech, annotated code, semantic models. Result, less manual work, more flexibility. Challenge, automating that integration smoothly. Application, easier adoption of CPS into current IT.
Project 3, the direct construction application.
Objective, improve construction execution. Use prototypes, real-time monitoring. Result, better execution, cost savings. Challenge, keeping physical and digital perfectly synced. Application, tracking components, crane safety, temporary works monitoring.
And Project 4, on quantity surveying.
Objective, better cost control. Method, interviews to find relevant tech. Result, potential for more precise, transparent cost tracking. Challenge, tailoring CPS for specific QS workflows. Application, optimized cost management, better project financial control. Yeah, it paints a picture of CPS tackling various critical points across the board.
It really does. Stepping back, it seems clear that CPS has this huge potential, really, to shake things up in construction and real estate. Efficiency, safety, sustainability, those are big wins.
They are, but as the sources stress, actually getting there, widespread adoption, it really depends on 2 big things.
Which are?
1, successfully integrating these new systems with what's already there, the complex existing stuff. And 2, user acceptance. People have to be willing and able to actually use these technologies effectively.
Which brings us back to that human-centered idea, HC-CPS.
Exactly. The tech needs to work for people. It has to be intuitive, helpful, not just powerful.
And these pilot projects show that people are actively working on these problems, right? Finding ways to make it happen and seeing real benefits already. Smoother construction, easier integration, better cost control.
Definitely. And one source made a really interesting comparison to the auto industry.
Oh, how so?
It suggested that construction, sometimes seen as maybe a bit slow on tech uptake,
Huh.
is now actually going through a similar kind of major shift, moving towards a future that's much more innovative, much more digitally connected. And CPS is right at the heart of that transformation.
So for you listening to this,
Hmm.
what's the big picture here? It feels like we're really at a turning point in how we build and manage buildings, our whole environment.
Yeah, it's more than just tweaking things. It's potentially reshaping the industry.
So the question becomes, how do people in the industry, businesses, professionals, how do they not just react, but actually take advantage of this?
Well, the sources kind of end on that note, suggesting that if the industry embraces these tools thoughtfully, it's a chance not just for efficiency or sustainability, but also to maybe boost the industry's image, attract new kinds of talent. It sort of leaves you thinking, okay, how could I or my company engage with this? What part of this shift is most relevant or maybe even exciting for me? It's definitely something to consider.
All right, well, that's a wrap for today. Thanks for joining us on this deep dive,
Yeah, thanks for having me.
and we'll catch you next time.
This was Revolution.
Where construction meets innovation. Until next time, keep building the future.